on number 1, it says to evaluate the following integrals and show all work. Now, section 5.3 is on the fundamental theorem of calculus, which definitely read through the boxes on this. But the main outcome of the fundamental theorem of calculus, well, at least part 2 of the fundamental theorem of calculus, there's a couple parts to it. But the main outcome is that really we can just solve these taking the integral and then plugging in the limits of integration and then subtracting those limits. So instead of going through all of the work of using the definition of the definite integral and using all the sigma notation and series, we can just integrate this using our integration rules and then plug in the two numbers and then actually figure out the area that way. So this is going to be a lot quicker than the previous section. So I want to integrate. So that's going to be 4x squared over 2 plus 6x. And I'm not going to put a c. So this seems counterintuitive because we always have to put c after we integrate. But here we don't have to. So I'm going to put we don't care about the c. Even if you would put it, it would cancel out in one of the next steps. So if you want to put, it will cancel out anyway. Let's simplify this integral, or this answer of the integral. This would be 2x squared plus 6x, and I'm evaluating this from 8 to 3. So these come from the limits of integration, which are right here. And what this means is that you're going to take the function and plug in 8 and then you're going to take the function and plug in 3 and then you're going to subtract them, specifically in this order. So if you figure out the value when you plug in 8, you should get 176, and then if you plug in 3, you should get 36, and then if you subtract these, you get 140. So if you compare this to number 7, so compared to 5.2, number 7, this is much faster doing it this way. This is the fast way of doing definite integrals. So again, very much like derivatives, we learn the long way and then the fast way. This is the fast way to the long way that we're doing in section 5.2. So this is the definite integral, and this number 140 represents the area, or I should say the net area. So definitely read the box about net area. And this was much easier to compute than using the definition of the definite integral in the previous section.